Hello students. Today we will discuss Hello students. Today we will discuss an example of simple harmonic motion, oscillation in a spring. Oscillation in a spring. Consider a block of mass m fixed to a spring and a spring fixed to a rigid wall at its another end. Also we are considering here the mass block rests on a smooth surface. So we are considering here the friction produced by the surface on the mass as negligible. Now if the block is pushed or pulled by some external force, what happens? The spring mass system will oscillate with respect to its initial or mean position, and that type of motion of the mass block or the spring is considered as simple harmonic motion. See here, the position of the equilibrium, or you can say the mean position of the mass, is the O. The point O denotes the equilibrium position of mass at its condition of rest. Now if we pull that mass with some external force, it will displace towards the right. If we push that mass with some external force, it will go towards the left and spring will be compressed. So in the previous case, the spring is expanded, and in the later case, the spring is compressed. In both of the conditions, the mass block is displaced by the external force far away from its mean position, towards the right or towards the left. At the same moment, when an external force is acting on the mass block, say initially, if we are pulling that block and the external force is denoted in the direction towards the right, then there will exist a restoring force in that spring which will be opposing the external force and which will be trying to restore the position of the mass block to its mean position. So the spring force will be acting here as Fs. So it is understood that if the mass block is pulled to the right, a restoring force acts opposite to opposite to external force. Restoring force acts in the spring towards left, which is given by here Fs equals to minus k x. This is also known as Hooke's law. Here in the above expression, k is a spring constant which depends on elastic property of spring, elastic property of spring material. So the k is large for a stiff spring and k is low for a soft spring. In the above relation of the force, the angular frequency of the oscillation omega is given by square root of k upon m, and since omega is denoted as 2 pi upon t, we can write it here. This will be equals to k upon m, or t equals to 2 pi square root of m upon k, the time period of oscillation. Remember here that the m denotes which is attached to the spring. So it is clear that a mass block system attached to a spring executes a simple harmonic motion when an external force is provided to it. That's all for that.